NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again in the universe. And we have no idea what it is, but we can measure it. Voyager 1, the iconic space probe launched by NASA over 4.5 decades ago, has just sent back a signal that has sent shockwaves through the scientific community. After traveling nearly 14 billion miles from Earth, Voyager 1 has made a discovery so profound that it has altered the course of its mission, turning back towards our planet. But what exactly could this discovery be? Could it be evidence of extraterrestrial life, a cosmic anomaly, or something even more unimaginable? In this gripping exploration, we'll unveil these shocking revelations as Voyager 1 just made a terrifying discovery that made it suddenly turn back towards Earth. History. The Voyager twin probes. If certain celestial events hadn't coincided, two of the most remarkable spacecraft ever launched might never have left Earth. In this case, the aligning stars were the four largest planets in our solar system. About 60 years ago, these planets were slowly aligning in a way that had last occurred during Thomas Jefferson's presidency in the early 19th century. This rare planetary alignment went largely unnoticed at first. The first person to recognize its significance was Gary Flandreau, a doctoral student in aeronautics at the California Institute of Technology back in 1965 when space exploration was just beginning. Working part-time at NASA's Jet Propulsion Laboratory in Pasadena, California, Flandreau was tasked with figuring out the most efficient way to send a space probe to Jupiter or even farther out to Saturn, Uranus, or Neptune. Using a simple pencil, he meticulously plotted the orbital paths of these giant planets and made a fascinating discovery. In the late 1970s and early 1980s, all four planets would align in a way that they could be visited in a single mission. This alignment meant that a spacecraft could use the gravitational pull of each planet to slingshot itself to the next, significantly reducing travel time. Flandreau calculated that this alignment would cut the flight time from Earth to Neptune from 30 years to just 12 years. However, there was a catch. This planetary alignment only occurred once every 176 years. To take advantage of this rare opportunity, a spacecraft would need to be launched by the mid-1970s. NASA seized this once-in-a-lifetime chance and built two spacecraft to make the journey. These spacecraft, Voyager 1 and Voyager 2, were sent on an incredible mission to explore the outer planets of our solar system. Thanks to the alignment of the planets and the visionary calculations of Gary Flandreau, the launch of the Voyager twin probes on September 5, 1977, was something truly incredible that happened at a place called Cape Canaveral in Florida. Voyager 1 embarked on its epic journey into space. Lifted off by a mighty rocket known as Titan 3E or Centaur, just 15 days after Voyager 2 was launched on August 20, 1977. Voyager 1 joined the cosmic adventure, beginning its voyage into the vast universe by following a shorter trajectory. Their primary mission was to explore the massive gas giants in our solar system, such as Jupiter and Saturn, along with their numerous moons. However, these intrepid space travelers surpassed all expectations. They ventured far beyond, pushing the boundaries of exploration, traveling farther and longer than any other spacecraft in history. They broke numerous records on their awe-inspiring odyssey. They have journeyed beyond anything created by humans before, even venturing into a region known as interstellar space, a completely uncharted territory within our galaxy. These trailblazing spacecraft, Voyager 1 and Voyager 2, are now more than 12 billion miles away from us. Despite their immense distance, they continue to astonish scientists with the remarkable discoveries they make out there. And most recently, they have made a discovery so unexpected that it has taken everyone by surprise. The Voyager twin probes have achieved some truly remarkable feats. Over 40 years ago, they scrutinized the moons of Jupiter and Saturn, astonishing scientists. Initially believed to be dull and hole-ridden like our moon, these moons turned out to be vibrant hubs of activity. Voyager 2 made history by becoming the first of the twins to swing by Uranus in 1986, and just 3 years later, it zipped past Neptune, a feat unmatched by any other spacecraft. As these spacecraft continue their incredible journey, NASA employed some clever strategies to ensure they remain operational. They've deactivated non-essential components, such as spare parts and heaters, to conserve power. This strategy aims to keep the spacecraft running smoothly until at least 2030. For the dedicated scientists and engineers who have been part of this extraordinary adventure from its inception, it's a bittersweet mix of emotions. Their hard work has paid off, and just when they thought the Voyager missions were nearing their end, a stunning discovery emerged from the depths of outer space. Voyager's discovery, data transmission, and Voyager's discovery. In the early days of their incredible journey 4 decades ago, the Voyager spacecraft amazed researchers by providing the first up-close views of the moons of Jupiter and Saturn. These moons, which astronomers had believed to be dull and heavily pockmarked like our own moon, turned out to be vibrant worlds. Voyager 1 reached Jupiter in March 1979, just 546 days after its launch. Voyager 2, following a slightly different path, arrived in July of the same year. Both spacecraft were equipped with Vidicon cameras that used filters to capture full-color images. Interestingly, they were designed to be very stable, spinning through space at a rate more than 15 times slower than the hour hand of a clock. This ensured that the images they captured were clear and sharp. During their mission, the Voyagers took more than 33,000 photographs of Jupiter and its moons, each revealing new and fascinating details. For instance, Europa, one of Jupiter's 53 named moons, was found to have a cracked, icy crust estimated to be more than 60 meters thick. As the spacecraft departed from the Jupiter system, they received a farewell boost in speed of 35,700 miles per hour from a gravitational slingshot, a crucial maneuver that helped propel them towards interstellar space. At Saturn, the Voyagers went their separate ways. Voyager 1 passed through Saturn's majestic rings, enduring thousands of impacts from tiny dust particles before flying past Titan, a moon enveloped in an orange haze, and heading northward out of the plane of the planets. Voyager 2 continued its solitary journey, reaching Uranus and Neptune in 1986. During its visit to Uranus, Voyager 2 discovered 10 new moons and added the planet to the list of worlds in our solar system with rings. However, Voyager 2's achievements were overshadowed by tragedy when just 4 days after its closest approach to Uranus, the Space Shuttle Challenger tragically exploded shortly after liftoff, claiming the lives of all 7 crew members, including Krista McAuliffe, a high school teacher from New Hampshire who was set to become the first civilian to travel into space. 3 years later, as Voyager 2 soared about 2,800 miles above Neptune's stunning azure methane sky, it encountered the swiftest winds recorded on any planet in our solar system, reaching speeds of up to 1,000 miles per hour. Neptune's largest moon, Triton, turned out to be one of the coldest spots in our cosmic neighborhood, with surface temperatures plummeting to a staggering minus 235 degrees Celsius. The moon's icy volcanoes were another remarkable find, ejecting nitrogen gas and fine particles up to 5 miles into its atmosphere. After Voyager 2's mesmerizing images of Neptune and its moons, both spacecraft were scheduled to power down their cameras, marking the end of their official mission. However, astronomer Carl Sagan, a member of the mission's imaging team, intervened. Despite the grand tour technically concluding, NASA had extended the mission with hopes that the Voyagers would venture into interstellar space. Renamed the Voyager Interstellar Mission, the spacecraft were set to continue their journey into the unknown. Sagan persuaded NASA to let Voyager 1 take one last series of images. On Valentine's Day in 1990, the spacecraft turned its cameras back toward the inner solar system and snapped 60 final shots. These images, famously referred to by Carl Sagan as the pale blue dot, captured Earth from a staggering distance of 3.8 billion miles. In the picture, Earth appears as a minuscule speck, barely visible against the vastness of space, illuminated by a faint glimmer of sunlight reflected off the camera's optics. We've learned so much about the planets and moons in our solar system. It's exciting to see how unique and fascinating each one is, even those that are farthest away. Voyager's journey beyond the heliosphere. In August 2012, Voyager 1 achieved an incredible milestone by venturing beyond the heliosphere, a vast region of charged particles emitted by the sun. This remarkable feat became widely known the following year when a study was published in the journal Science, sharing Voyager 1's groundbreaking discovery. The spacecraft's plasma wave instrument detected a powerful solar eruption between April 9th and May 22nd, 2013. This event caused electrons near Voyager 1 to vibrate, indicating that the spacecraft had entered a region of higher particle density than that found just inside the heliosphere. At first glance, it might seem surprising that the electron density is greater in interstellar space than near the Sun. However, researchers explained that the electron density at the heliosphere's edge is significantly lower than at Earth's surface. Analyzing Voyager 1's data, researchers pinpointed the official departure date as August 25, 2012. This determination was not based solely on electron oscillations, but also on measurements of charged solar particles collected by the spacecraft on that significant day. Coincidentally, this was also the day that the renowned Apollo 11 astronaut Neil Armstrong passed away. On this pivotal date, Voyager 1 detected a remarkable thousand-fold decrease in solar particles and a 9% increase in galactic cosmic rays originating from outside the solar system. These findings shed light on the dynamic and ever-changing nature of our cosmic neighborhood, showcasing the vastness and complexity of space exploration. Voyager 1 reached an astonishing distance of 11.25 billion miles from the Sun, which is about 121 astronomical units. At this point, NASA's Planetary Science Division was diligently exploring the solar system using a series of methods, including flybys, orbiting, landing, roving, and returning samples. The Voyager missions, serving as the pioneers and architects of this approach, laid the foundation for future exploration. The Voyager spacecraft played a crucial role in surveying the universe and shaping our research priorities. By conducting flybys, these missions greatly enhanced the success of planetary science. The concept of gravity assist, which involves using the mass of a planet or another celestial object to change the speed and path of a spacecraft, was essential for Voyager's successful exploration of the outer planets. Scientists and astronomers, in their quest to fully understand gravity assist, made a surprising discovery about the vastness of outer space. The Deep Space Network. Despite relying on gravity assist maneuvers for space navigation, the Voyager missions had another crucial element: the Deep Space Network (DSN). This element is like a cosmic telephone line that kept us connected with our intrepid Voyager probes as they ventured into the unknown. So, what exactly is the Deep Space Network? It may not be as flashy as a spaceship, but it's incredibly vital. The DSN is like a vast web of radio antennas scattered across the globe, from California to Spain to Australia. These mammoth dishes, some as wide as 70 meters, act as space megaphones, enabling us to communicate with spacecraft that are way out there. Then what's its role in the Voyager missions? The Voyager probes, equipped with cameras and sensors, were our eyes and ears in space. To make sense of the data they sent back and to give them instructions, we needed a robust communication system, and that's where the DSN played a pivotal role. When Voyager 1, journeying to the outer reaches of our solar system, sends a message back to Earth, it's a faint signal racing incredibly fast through space. By the time it arrives on Earth, it's barely a whisper. But fear not, the DSN's colossal antennas are poised to catch that faint signal. They lock onto Voyager's whisper and transform it into usable data for scientists. The Deep Space Network isn't just about catching signals. It also sends commands. Missions like Voyager are dynamic, requiring scientists and engineers to adjust plans or give instructions to the spacecraft. These commands are sent through the DSN, traveling through space to reach Voyager. It's like having a two-way conversation between Earth and the most distant human-made objects in space. One remarkable aspect of the DSN is its constant operation, 24/7, always listening for those distant signals. It's more than just a collection of antennas. It's our vital space connection. The DSN keeps the stories of the Voyager missions alive, even as the spacecraft ventures far beyond our solar system, exploring the uncharted territories of interstellar space. Challenges faced by Voyager probes. The extended journeys of the Voyager spacecraft have been filled with unexpected challenges. Voyager 1, in particular, is equipped with 3 onboard computers, including a flight data system responsible for collecting information from the spacecraft's scientific instruments and bundling it with engineering data to monitor Voyager 1's health. This data is then sent to mission control on Earth in binary code, which is a series of ones and zeros. Recently, however, Voyager 1's flight data system seems to be stuck in a loop, repeatedly sending the same pattern of ones and zeros back to Earth. This issue was first noticed on November 14th, when the spacecraft's telecommunications unit started behaving erratically. While Voyager 1 can still receive and execute commands from mission control, this problem means that no new scientific or engineering data is being transmitted back to Earth. NASA engineers have attempted to restart the flight data system, but so far, no usable data has been received. They are now working to identify the underlying cause of the problem before deciding on the next steps to fix it. This process could take several weeks. Interestingly, this is not the first time Voyager 1 has experienced issues with its flight data system. A similar problem occurred in 1981. However, the current problem does not seem to be related to any other glitches the spacecraft has encountered in recent years. As the Voyager probes face new challenges, the mission team is relying on manuals written decades ago for guidance. These manuals, while comprehensive, could not have predicted all the challenges the spacecraft would encounter as they continued their journey through the cosmos. The team is taking a cautious approach, carefully considering all potential implications before sending any more commands to Voyager 1 to ensure that its operations are not unexpectedly impacted. Voyager's distance and communication challenges. Voyager 1 has positioned itself so incredibly far away that it takes a whopping 22.5 hours for signals to travel from Earth to the spacecraft. And that's not all. It takes another 45 hours for the team to receive a response. Imagine waiting almost 2 days just to hear back from a spacecraft. As the Voyager twins continue their epic journey through space, the team has had to make some tough decisions to keep them going. They started turning off some instruments on these aging probes to save power and prolong their missions. Along the way, both spacecraft have faced unexpected problems, like a 7-month period in 2020 when Voyager 2 couldn't communicate with Earth. In a stroke of luck, the team managed to restore communication in August using a clever technique that realigned the spacecraft's antenna. While the team is hopeful about restoring the regular flow of data from Voyager 1, the real value of these missions lies in their longevity. Scientists are eager to study how particles and magnetic fields change as the probes venture farther from the heliosphere. However, this valuable data set will be incomplete if Voyager 1 can't send information back. The team has also been innovative in finding ways to extend the power supply on both spacecraft. Despite the challenges, the Voyager missions have far surpassed their initial expectations, outlasting any other spacecraft in history. So while the engineers are working tirelessly to keep them going, they also know that more challenges may lie ahead. Despite their dwindling power, the voyages of these spacecraft are far from over. Interstellar space, the Oort cloud, heliosphere, and heliopause. Getting to interstellar space is easier than reaching the farthest reaches of our solar system. Imagine the solar system as a balloon with a faraway cloud of comet-like objects called the Oort cloud, held in place by the sun's gravity. This Oort cloud might stretch halfway to the nearest star, and it will take the Voyager probes about 300 more years to reach its edge. Now, when we say interstellar space, we're talking about the area beyond where the solar wind, a stream of charged particles and magnetic fields from the sun, stops. The solar wind acts like air blowing up a balloon, creating something called the heliosphere. This is like a protective bubble around the solar system carried by the solar wind. Eventually, this bubble is halted by pressure from interstellar matter, creating a boundary known as the termination shock. The border between our solar system and interstellar space is called the heliopause, and it's estimated to be quite far away. Initially, some thought it was as close as Jupiter, but more accurate calculations in 1993 placed it around 25 times the distance from Earth to the Sun, which is 1 astronomical unit, AU. Voyager 1 reached this boundary about 20 years after these calculations, detecting a rise in plasma density. Voyager 2, on the other hand, reached the shore of interstellar space in 2018, but it didn't observe any changes in the magnetic field. This was surprising, as theories had predicted fluctuations tied to the Sun's 11-year cycle. The solar wind was at its strongest when Voyager 2 arrived, challenging these predictions. As the Voyager probes provide real data, scientists are refining their models of how the heliosphere interacts with interstellar space. In simpler terms, our Sun has left a hot, ionized zone and entered a partially ionized section of the galaxy. The hot zone likely formed when nearby ancient stars exploded in supernovae, heating the space and affecting nearby atoms. It's like the seaside with swirling waves and water. It's a bit tumultuous in the lively area near the heliopause. Magnetic fields twist and turn in ways that surprise scientists. Instead of the smooth patterns typically envisioned, the Voyagers discovered a dynamic environment with lots of small changes, though they didn't observe significant differences in magnetic fields on larger scales. Eventually, the spacecraft will venture beyond this turbulent region and encounter the pure magnetic field of interstellar space. Voyager's ongoing journey and power challenges. As we bid farewell to these remarkable spacecraft, it's important to note that both Voyager probes are still operational, thanks to a system that converts heat from plutonium's decay into electricity. However, their power output decreases by about 4 watts each year, which has put the mission team in a challenging position. Although it's fascinating to watch the Voyagers continue their journey, the time is coming when we'll have to say goodbye. Despite this, the probes will continue exploring even if they can no longer communicate with us. Voyager 1 is on track to pass by Proxima Centauri, our neighboring star, in a staggering 16,700 years, while Voyager 2 will follow about 3,600 years later. After this, they will continue their voyage through the galaxy for millions of years, long after our Sun has faded and the heliosphere has vanished. All of this just to explore the speck we call home, a journey that seems to have no end. While the Voyagers may still be out there, their condition is uncertain. There's a possibility they could send a final message during their journey, but it wouldn't be through radio communication and wouldn't be intended for U.S. humans. Detection of mysterious humming sound. Voyager 1 picked up a strange humming noise coming from outside our solar system. This discovery was made by Stella Koch, a student studying space at Cornell University. She and her team found this humming sound in the data from Voyager's plasma wave system, which measures how many electrons are in space. Even though the hum is quiet and sounds repeatedly, scientists are puzzled by it. They think it could give us clues about how space works beyond our solar system and how it interacts with the area around the Sun. The humming might help us understand how the gas in space is disturbed by the Sun. Voyager 1 has been a big help in teaching us about space. But recently, Voyager 1's communication issues. Voyager 1 has been causing some trouble for NASA. The part of the spacecraft that controls its movements and its big antenna isn't sending back the right information, even though it seems to be working fine. The data it sends back is all mixed up. This hasn't caused the spacecraft to stop working or to do anything wrong. It's still able to get commands from Earth and follow them. The team in charge of Voyager is working hard to figure out why the data is wrong and how to fix it. Suzanne Dodd, who leads the team managing Voyager 1, is confident they'll solve the problem. The spacecraft is almost 45 years old, way older than most electronics, and it's in a place it wasn't designed for. Despite the challenges, the team is determined to keep Voyager 1 exploring space. The Voyager tapes. Interestingly, the Voyager probes use a fascinating piece of technology, an ancient 8-track tape system. That's right, the same kind of tapes that were all the rage in the 70s. It's incredible to think that these probes are still relying on this technology, but it just goes to show how clever the mission planners were. They made sure that these old tapes could still get the job done, even after all these years. But why 8-track tapes, you might ask? Well, back when space exploration was in its early days, the digital storage methods we use today were just starting to be developed. Engineers needed something durable and reliable to store the valuable data collected by the Voyager probes. And surprisingly, those old 8-track tapes turned out to be the perfect solution. What's even more fascinating is the kind of data stored on these tapes. It's not just your average music playlist. It's crucial scientific information about planets, moons, and the vast expanse of space between the stars. These tapes contain the key to unlocking some of the universe's greatest mysteries, making them incredibly valuable and important. Subscriber pick: Voyager's discoveries. Now it's time for today's subscriber pick. Voyager 1, since its launch, has been on a historic journey through the cosmos. It has already surpassed the bounds of our solar system and ventured into the unknown depths of interstellar space. As it cruised through the silent expanse, Voyager 1 sensors picked up something unexpected, a faint, strange humming noise that seemed to resonate from the very fabric of space itself. Scientists at NASA were baffled. What could be causing this strange phenomenon? Was it a sign of some cosmic anomaly, or perhaps a message from a distant civilization? As they puzzled over this mystery, Voyager 1 made another startling discovery. Its cameras captured images of a vast, swirling cloud of gas and dust stretching across millions of miles. Voyager 1 continued its journey, leaving behind a trail of questions and wonder. Voyager 1 just made a terrifying discovery that caused it to suddenly turn back towards Earth. Astronomers have been left wondering about the many unknown mysteries that still lay beyond the stars. But could this mysterious discovery be the very cause of Voyager 1's destruction? Let us know your thoughts in the comments below. Goodbye, Voyagers. The excitement is palpable as these old spacecraft get closer to a big moment in their journey. They're leaving behind the rough parts of the outer solar system and heading towards the clean, open space of the interstellar magnetic field. But saying goodbye to these groundbreaking travelers will be emotional. Ending any long, amazing journey is always sad. Right now, Voyager 2 has 5 working tools, while Voyager 1 has 4. They've lasted so long because of a special power source that turns the heat from decaying plutonium into electricity. Voyager 1 will pass by Proxima Centauri, the star closest to us, in an incredible 16,700 years. Voyager 2 will do the same, but it'll take another 3,600 years. These strong travelers will keep moving around the galaxy for millions of years, long after our sun dies and the heliosphere disappears. Even when they're silent, these spacecraft might carry a final message. They hold 2 old-fashioned copper records covered in gold, sealed in aluminum. These records have sounds and pictures that show what life on Earth is like. They have 90 minutes of music from Bach to Chuck Berry, and they show things like children laughing, dolphins dancing, sunsets, and crickets chirping. These recordings capture who we are, telling our story to the universe. Jimmy Carter, the president when the Voyagers were launched, added a message too. It says, "We send this message into space hoping that one day when we've solved our problems, we can join a community of civilizations from other galaxies." This record shows our hope, our determination, and our goodwill in a vast and amazing universe. The Voyagers, quiet messengers from Earth, keep exploring the endless space between stars, carrying our story and our dreams of connecting with others out there. The fate of Voyager's golden records. Nick Oberg, along with a colleague, conducted thousands of simulations to track the paths of the Voyager spacecraft and their encounters with dust clouds. They simulated the potential damage the golden records might face along their journeys. This work also involved considering the possibility that a cloud's gravity could alter the spacecraft's trajectories. Oberg explained that these clouds have such immense mass concentrated in one area that they could actually bend the spacecraft's path and send them into new orbits, sometimes much farther out or even deeper toward the galactic core. Both golden records have a good chance of remaining legible since their engraved sides are safely tucked away against the spacecraft bodies. However, the outer surface of Voyager 1's record is more likely to erode over time. On the other hand, the information on Voyager 2's record is more likely to become illegible. This is because Voyager 2's orbit is more chaotic and much harder to predict accurately, making it uncertain what kind of environment it will encounter. Despite these challenges, this is because it is around this time that the Milky Way is expected to collide with its massive neighbor, the Andromeda Galaxy, leading to a period of chaos and uncertainty in the galaxy's paths. Let us know your thoughts about this gallant spacecraft in the comments below. See you in the next video.